All right, so we're going to look at the optimization model here. And I've got 3 suppliers of water that's been purified in some way, shape, or form at some quality level, as you see over here in the gray data right in here. Okay, so we got that cost stuff here. I'm just going to change it into a slightly different color. Feel free to go ahead and do this for your needs. And then this is the quantity available. So we'll color that a little bit different just for our own needs here, because that's going to be important, because our company is required to order 1,000 in quarter 1, 1,000 in quarter 2, and 1,000 in quarter 3. Because we have to manufacture these packs. We have to put them in, we have to bottle them, we have to put them in the plastic wrap and all those things. And our factory can only handle 1,000 of these a month, or a quarter, whatever the time period would be in your actual business. We have to, and this is subject to, so whenever you hear the word subject to, it means a constraint. Subject to, this first supplier only has 1,000 available. Second one only has 300 available, so that'll barely cover our needs, right? For just a fraction of our time here. And then McCollum Springs with 2,400. You know, if I were to just quickly add these up, just highlight them and go down here, you would see that there are 3,700 units. So that suggests to me, just using business logic, common sense, that I'm going to need to buy from all 3 suppliers. Because if I need a total of 3,000 and no single supplier has 3,000, you know, I'm going to have to buy a little bit from, I mean, I could probably get away with Hafele and McCollum because together they equal greater than 3,000. But what you want to be careful of is, you know, how does that work with the other variables over here as well there? So, you know, is Hafele's pH going to be satisfactory? You know, does Ratajczyk at a lower cost than McCollum offer any opportunity to lower our cost, right? So it's one thing to just buy from these 2 because you know that they equal greater than 3,000. That's great. But look at McCollum's cost over here. That is twice as much as Ratajczyk's. So the model should pick up on that and say, hey, I know that we could consolidate and only buy from 2 suppliers, but those 300 units that I would buy from Ratajczyk instead of McCollum, let's just do this math here just so you understand it. Take the 650 times the 300. So I would be spending $195,000 on Ratajczyk's 300 units, whereas if I were to spend the same amount times that 300, now I'm manually typing in 300 because I can't just take 2,400, I am spending $420,000 for a difference of over 215%. So I'm paying more than 100%. I'm paying a ton more. So the model should pick up on that if you do the model successfully, and it will order 300 units from Ratajczyk, a bunch from Hafele as well because he's cheaper than McCollum, subject to these conditions being satisfactory to our model, leaving McCollum to what we call hold the bag, meaning we get the rest from that supplier. Okay, so look at that difference there. That's what we're talking about when we do an optimization model. Okay, so how do we have this set up? You will be responsible for setting all of this up. Okay, I will not provide this to you. This is the answer key, if you will. I will give you this stuff, right? I'll just give you these things right here. I color them the same way because they're going to be related to items up here. So a couple things you need to do first. One, you need to do the sum product function. And if you don't remember the sum product function, basically what it does is it takes this times this plus this times this plus this times this. It's basically just multiplying a lot of cells and adding them together. Hence the word product, which means multiplication, and sum, which means adding together. Okay? Now, one problem you might have if you do a sum product function is if you set it up and you put a 9 here, you know what I mean? Like, the sum product has to have the same ranges in each section. So C6 to C8, see the 6 there and the 8? It has to have a 6 and an 8 over here as well if you set it up with using these, you know, in this model right here. You don't know what I'm going to give you on the final exam. I could give you 6 suppliers. I could give you 20 suppliers. The same principle would apply here. Okay? Now shipping is the same way, still some product, but this time when we're still using the stuff in here, but this time we're multiplying against the shipping data. Okay, so that's that sum product. What do you want to multiply first, and then what do you want to multiply it against, right? So I want quantity because that's the name of the game, right? This up here is created because we have to buy quantity, right? Subject to the price, subject to fulfilling these arrangements. So you're always going to multiply by quantity when you do these models. You're going to multiply it by something else like price or shipping, something along those lines. Total ordered is the sum of these. Now remember, and I'm going to color this green, Excel gets to play in here. Solver gets to play in this green stuff here and decide, do I order 500 from Hayful, and then 200, and then 300? Solver gets to play with those decisions, okay? Now, this is given to you. It could be 400 one month. I could say 110 the next month, and then I could say something along the lines of 900 the other month. So you really have to understand your formulas because, and set it up properly in Solver, which we'll get to in a moment. Now down here is a little trickier. What I want you to note though is it's the same thing. It's the same sum product technique as you did up here, but instead of multiplying by price or shipping, you're now multiplying it by one of your variables, right? So in this case, we're multiplying it by the pH level because it says pH level over here. When you go down here and it says nodule quality, you are multiplying it by the nodule quality. Now the only difference is we are dividing it by C13, which is a total required. The reason we're doing that is because we need to get it down to a per unit basis. Because if you think about it, we're multiplying by quantity up here times 8. So if we order 1,000 of these and we multiply it by 8, that's 8,000. Okay? If we didn't do that, let's just get rid of that C13 here. There's our 8,000. We will never, ever honor some of these constraints down here, okay? So we have to divide it out, and in fact what we're doing is we're neutralizing that sum product a little bit. We're bringing it to what's called a weighted average, okay? So don't forget that you're going to divide by the total required down here, okay? Especially these down here. Let's just pretend we don't do that here. So now I've got 20,000 because I multiplied that 1,000 times the 20, and I got 20,000. I will never, ever be able to honor this less than equal to 60 because I didn't divide it by the total quantity ordered. But now I can. So that's very important. When you do all these things, and I'll just get rid of this here, and we'll rerun Solver. Oops. So Solver, this is a little trickier. You got to take a little bit of time with this and practice. We always want our objective to be, over here someplace, right? We want to minimize. Okay, a couple of you on the second exam, you hit maximize and you got a really bad number because you're basically saying, hey, I want to buy all this stuff, but I want to pay the most, right? Companies don't want to pay the most. They want to pay the least amount possible. Okay? Down here, this is where Excel gets to play. So in the green stuff there. And then these are all of your constraints, right? So this stuff down here is going to be in your constraint list. So look at 19, 20, 21, 22. There's 19, 20, 21, and 22 right there. They're not in the right order. It doesn't matter. But then we've got a couple of other things here. The total ordered row 11, okay, must equal row 13. Right? Sorry, row 12. I misspoke there. So there's that. Everything in here must equal what's right below it. We have to order 1,000 each month. So that's what this constraint is saying. Now we do have another constraint over here. All of these numbers here have to be less than or equal to these numbers. I cannot, for example, order 1,001 unit from Hayful. I am not allowed to do that because Hayful only has 1,000 units. Okay, I can't even order this much from Hayful because he doesn't have that fraction of a billionth or whatever that number would really be. Probably be a zillionth, right? So you have to program that into your solver to say F6 through F8 has to be less than or equal to these numbers here. Okay, when you do that, you're running a proper solver. You're saying, I want you to buy up to 1,000. I want you to buy exactly 1,000 units in quarter one, based upon these rules being honored, and based upon the cheapest price possible. Now, that's an and, not an or. So you have to do this and the cheapest price possible, which is determined down here, right? In a sum that takes that stuff there. So